Does Trenbolone really upregulate IGF1 and/or IGF1 receptor sensitivity? Well, the answer is pretty nuanced. Let's get into it. I'm sure most of you know what Trenbolone is, but here is a brief overview for those not familiar with the compound. Trenbolone is an extremely potent anabolic androgenic steroid that is produced by taking nandrolone and adding 2 extra double bonds to the ring system. Nandrolone has a single double bond at C4. Trenbolone carries additional double bonds at C9 and C11, converting it from a delta-4-ene to a delta-4-9-11 triene. These modifications are responsible for Trenbolone's extremely potent effects, with a binding affinity roughly 3 to 4 times higher than testosterone at the androgen receptor. These modifications are also responsible for Trenbolone's inability to interact with the aromatase enzyme or 5-alpha reduce. Now let's get into the supposed effects of Trenbolone on IGF1. All the studies we'll be reviewing are on animal models, or in vitro studies, due to human studies of Trenbolone being practically non-existent. The first study we'll be reviewing is where researchers gave rats Trenbolone injections in vivo, then isolated satellite cells and tested their proliferative responses to FGF and IGF1 in culture. The key findings were that satellite cells taken from Trenbolone-treated rats had greater proliferative responses to IGF1 and FGF than cells from the control group. Serum from Trenbolone-treated rats also stimulated more proliferation than the control group, suggesting Trenbolone exposure increases satellite cell sensitivity/responsiveness to IGF1. The second study administered Trenbolone acetate in combination with estrogen in cattle. The treated group had upregulated IGF1 mRNA in the liver, alongside upregulated androgen receptors, while several other metabolic/insulin-related genes were downregulated. Authors conclude that the effect on IGF1 that Trenbolone plus estrogen had was likely responsible for some of its growth effects in cattle. The third and final study implanted steers with Trenbolone acetate plus estrogen and tracked serum IGF1, IGF-binding proteins, and mitogenic activity up to 143 days. The implants raised circulating IGF1 by about 16 to 22%, increased early IGF1 binding proteins after implantation, and serum from implanted steers stimulated muscle satellite cell proliferation in vitro. In short, Trenbolone in combination with estradiol boosts systemic IGF1 and IGF binding proteins, as well as serum mitogenicity. There are 2 very important caveats to my research. While preclinical work suggests Trenbolone can increase local IGF1 signaling, for example, muscle IGF1 mRNA and satellite cell responsiveness. However, most of the studies I reviewed combined Trenbolone with estrogen, which has very strong independent actions on the GH-IGF1 axis on cattle. Because of this, I can't conclude that Trenbolone alone will have positive effects on IGF1/IGF1 receptor sensitivity, especially in humans.